Đoàn Hồng Nam, can you hear me? Dương Huỳnh My.
Hello, teacher.
Yes, thank you. So you all can hear me, okay? 86 students. Just wait, okay? I will start when there are over 100 students in the class, okay? Okay, so I think we should start our today lesson, okay? So let's start by watching two video clips. I'm going to show you two video clips, okay, with the sound. Let's rewatch the video clips, okay? I'll show you on Monday. But now to watch this video clip with audio, okay?
To understand the process of breathing. In humans, the main organs responsible for respiration are present in the thoracic cavity. In the thorax region, the rib cage and a dome-shaped fibrous tissue, known as the diaphragm, are observed. Present within the rib cage are the pleural membranes, which enclose the lungs. The right lung is divided into three lobes: the right superior, right middle, and the right inferior lobe. The left lung is smaller and has only two lobes, the left superior and the left inferior lobe. Both the lungs are associated externally with small tubular bronchi, which unite and extend into the trachea. The trachea has incomplete C-shaped rings of cartilage, which prevent the tracheal wall from collapsing. The trachea leads into the pharynx, which is connected to the nostrils. As we breathe in air, the oxygen molecules enter the nostrils and travel downwards through the pharynx and trachea to finally reach the bronchi. From each bronchus, oxygen travels into the lungs. Within the lungs, the bronchus divides repeatedly to form bronchioles. Oxygen travels through these bronchioles and reaches the alveoli, each of which is surrounded by a network of capillaries. A section of one alveolus shows the presence of numerous alveolar chambers with pores. Blood containing RBCs is seen flowing through the capillaries. The oxygen molecules from the alveolus diffuse into the capillary and then get absorbed by the bluish-purple RBCs. This causes oxygenation of the RBCs, and a transition in their color from bluish-purple to red is observed. The blood moving into the alveolus contains RBCs and carbon dioxide molecules. These molecules are released into the alveolus. The carbon dioxide collects in the alveolar chamber. And then from the alveolus, it travels through the bronchioles, into the bronchus, which finally reaches the trachea and is breathed out through the nostrils. So the process of breathing in air rich in oxygen is called inhalation. After the contraction of the muscular diaphragm, the lungs expand and the air rushes in, resulting in the inflation of the alveoli. During exhalation, the diaphragm moves up and the lungs contract. Thus, the alveoli deflate, causing the air to be forced out. This air is rich in carbon dioxide. This process of inhalation and exhalation is known as respiration, which is approximately 20 times per minute. Summary.
Okay, so I stopped the video here. Okay, so we continue watching another video, okay, about gas exchange, okay. So this video will help you understand better, okay, about the gas exchange which occur inside your lungs, okay.
Many of us have hundreds of things on our minds at any moment, often struggling to keep track of everything we need to do. But fortunately, there's one important thing we don't have.
Watching again.
Many of us have hundreds of things on our minds at any moment, often struggling to keep track of everything we need to do. But fortunately, there's one important thing we don't have to worry about remembering: breathing. When you breathe, you transport oxygen to the body's cells to keep them working, and clear your system of the carbon dioxide that this work generates. Breathing, in other words, keeps the body alive. So how do we accomplish this crucial and complex task without even thinking about it? The answer lies in our body's respiratory system. Like any machinery, it consists of specialized components and requires a trigger to start functioning. Here, the components are the structures and tissues making up the lungs, as well as the various other respiratory organs connected to them. And to get this machine moving, we need the autonomic nervous system, our brain's unconscious control center for the vital functions. As the body prepares to take in oxygen-rich air, this system sends a signal to the muscles around your lungs, flattening the diaphragm and contracting the intercostal muscles between your ribs to create more space for the lungs to expand. Air then whooshes into your nose and mouth, through your trachea, and into the bronchi that split at the trachea's base, with one entering each lung. Like tree branches, these small tubes divide into thousands of tinier passages, called bronchioles. It's tempting to think of the lungs as huge balloons, but instead of being hollow, they're actually spongy inside, with the bronchioles running throughout the parenchyma tissue. At the end of each bronchiole is a little air sac called an alveolus, wrapped in capillaries full of red blood cells containing special proteins called hemoglobin. The air you've breathed in fills these sacs, causing the lungs to inflate. Here is where the vital exchange occurs. At this point, the capillaries are packed with carbon dioxide, and the air sacs are full of oxygen. But due to the basic process of diffusion, the molecules of each gas want to move to a place where there is a lower concentration of their kind. So as oxygen crosses over to the capillaries, the hemoglobin grabs it up, while the carbon dioxide is unloaded into the lungs. The oxygen-rich hemoglobin is then transported throughout the body.
Okay, so this is how the gas exchange occurs, okay? So you have to watch this part carefully.
Via the bloodstream. But what do our lungs do with all that carbon dioxide? Exhale it, of course. The autonomic nervous system kicks in again, causing the diaphragm to ball up and the intercostal muscles to relax, making the chest cavity smaller and forcing the lungs to compress. The carbon dioxide-rich air is expelled, and the cycle begins again. So that's how these spongy organs keep our bodies efficiently supplied with air. Lungs inhale and exhale between 15 and 25 times a minute, which amounts to an incredible 10,000 liters of air each day. That's a lot of work, but don't sweat it. Your lungs and your autonomic nervous system have got it covered.
Okay, I hope that after watching the two video clips, okay, you understand more about how the respiratory system works, okay, and how the gas exchange happens inside your lungs, guys, okay? Now we continue with the lesson. Okay, so let's talk about this one, the gas exchange, okay? Okay, so today we will continue with the reading practice, okay? I have this text, and I think I will give you 3 minutes to skim read this text, okay? Gas exchange. Please skim read by yourself, okay, in 3 minutes. Okay, I think I will ask someone to read the text for me, okay? Dương Huỳnh My.
Yes, I'm here.
Okay, so can you help me skim read? Can you help me read the text, please? Let's start with the first paragraph as discussed earlier. Let's go.
Yes. As discussed earlier, the main role of the respiratory system is to provide oxygen for the body and to reach the bodies of waste gases such as carbon dioxide. Gas exchange takes place between the alveoli and pulmonary capillaries in the lungs. To understand how gas exchange takes place, let's first look at the basis and
Anatomy.
at yes
Anatomy.
anatomy of the alveoli and capillaries in the lungs.
Okay, thank you, girl. Next one, Dương Tiến Khang. Can you unmute yourself and continue reading? Second paragraph, please.
Yes, sure. Alveoli are comprised of
Elastin.
elastin fiber, the same fiber found in your skin that allow your skin to magnify its alveolar structure, and when you expire, it returns to its original size. Its alveolus is closely surrounded by capillaries, the walls of both the alveoli and capillary has something that oxygen and carbon dioxide can travel between the alveoli and capillary easily.
Thank you. Next one. Kru Tanvi, can you continue reading the third paragraph, please?
Yes, I'm here.
Okay, let's go. How do oxygen? Let's read.
How do oxygen and carbon dioxide travel between the alveoli and capillaries? Blood flow in oxygen is carried from the heart to the lungs by the pulmonary artery. Recall what you learned in the cardiovascular chapter. Pulmonary capillary, the
The ultimate
final range of the pulmonary arteries surround each alveolus. When capillary bring carbon dioxide to the alveoli, the carbon dioxide easily passes through the alveolar wall. It travels to the center of each alveolus and then
expired.
expire out of the lungs. Likewise, when you expire, oxygen travels down your respiratory tract to your lungs, enter the alveoli, and then pass through both of alveolus wall and the pulmonary capillary wall to enter the capillary. Once inside the capillaries, oxygen enters the red blood cell and then attracts to the hemoglobin.
Yes.
The blood is now higher oxygenated and travel back to the heart via pulmonary veins. The rosette of gas exchange takes place
simultaneously.
In other words, oxygen is entering the capillary at the same time as carbon dioxide is exiting the capillaries.
Thank you so much, girl. Okay, so in this text we have a new word. Simultaneously means happening at the same time. Okay, now next students, we continue with the gas exchange. Okay, oxygen and carbon dioxide gas exchange. Lê Thị Quỳnh Anh. Hello, Quỳnh Anh. Good morning. Can you unmute yourself?
Yes, hello teacher.
Okay, so can you help me to read the first paragraph of gas exchange, oxygen and carbon dioxide?
The process that allows oxygen and carbon dioxide to move into and out of the bloodstream is called diffusion. Diffusion is the net movement of molecules from one area that has a higher concentration amount of these molecules toward into an area where there is a lower concentration of the molecules. For example, when capillaries bring carbon dioxide to the alveoli, there is more carbon dioxide in the capillaries than there is in the alveoli.
Yes.
Therefore, the carbon dioxide will more likely to move into the alveoli than out of them. Likewise, when oxygen molecules enter the alveoli, they are more likely to move into the capillaries, where there are fewer oxygen molecules than stay in the alveoli, where there are more oxygen molecules. Continue. You might be tempted to think that molecules move into the empty space because they are empty. However, this is not so. Net movement is simply to the result of the random movement of molecules. Molecules move all the time and they move to the empty areas because they are not blocked by other molecules. Net movement means that the majority of molecules are moving into the direction of empty space, but not all of them. Here is an example of net movement.
Hello everyone, I'm back. Sorry for the failed internet connection. Back, okay? Can you just wait and we're gonna start again. Sorry for the bad connection. Okay, so we're gonna start again. Can you just wait for a minute and we continue? Okay, so I'm back with this one. Okay, so Lê Thị Quỳnh Anh, can you please help me to reread this one? Spell it one more time because last time, okay, the internet connection was bad and I was out. Now I'm back.
Okay.
Okay, yes, can we restart again? Thank you so much. Let's go.
The process that allows oxygen and carbon dioxide to move into and out of the bloodstream is called diffusion. Diffusion is the net movement of molecules from one area that has a higher concentration amount of these molecules toward an area where there is a lower concentration of these molecules. For example, when capillaries capillaries bring carbon dioxide to the alveoli. There is more carbon dioxide in the capillaries than there is in the alveoli. Therefore, the carbon dioxide will more likely move into the alveoli than out of them. Likewise, when oxygen molecules enter the alveoli, they are more likely to move into the capillaries, where there are fewer oxygen molecules than stay into the alveoli, where there are more oxygen molecules.
Okay, thank you girls so much. Okay, so to understand, you have to know how diffusion works. Okay, so you know, like the amount of molecules, okay, they have the tendencies to move into the area where there is a low concentration, okay, of those molecules, right? Okay, so that's how the basic diffusion works. Have to understand. Okay, now the next paragraph, please. Lung Ngọc Lâm, can you unmute yourself?
Yes.
Okay, so can you help me read the next paragraph? You might be tempted to think. Let's go.
Okay. You might be tempted to think that molecules move to the empty space because they are empty. However, this is not so. Net movement is simply the result of the random movement of molecules. Molecules move on up the time and they move to the empty areas because they are not blocked by by other molecules. Net movement means that the majority of molecules are moving in the directions of emptier space, but not all of them. Here's an example of net movement.
So let me continue reading. Imagine that two containers in figure 10.7 are separated by a membrane, like the outer covering of a cell, and that this membrane has holes big enough for the blue molecules to pass through. Now imagine all the blue molecules are bouncing around inside the containers. The molecules on the left side frequently bounce off one another because there are more of them. Some of them just happen to, by chance, go through the membrane to the other sides. The molecules on the right side, however, have lots of empty space in which to move. It is less likely, but still possible, that one of them will move through the membranes to the left side. Okay, so I think you need to focus on the first paragraph to understand how diffusion works. Okay, and for this one. Okay, so this is the last paragraph that you have to read and to get more information. Lương Thị Ngọc Hân.
Hello, teacher.
Okay, can you help me read this paragraph, please? Finally.
Yes. Finally, in order for gas exchange to take place, the alveoli must be inflated. If the alveoli are collapsed, then no air can flow into them, and there will be little oxygen to extract, because there is water in the air that you breathe. Water ends up.
Read, not rap, read.
Breathe.
Yes.
Water ends up in the alveoli. If only water lie the alveoli, the water molecules would be attracted to one another and pull the alveoli close. They would collapse and you could die. Therefore, alveoli are kept inflated by molecules called
Surfactant. Surfactant.
Surfactant. Surfactant is the
Detergent.
detergent, a molecule that prevents the algae from collapsing by mixing with the water that lies in the inside of the alveoli. The surfactant molecules keeps the water molecules away from one another and therefore keep the alveoli inflated. Surfactant is produced by large volatiles in the walls of the alveoli.
Thank you so much, Mary. Okay, so now we have some questions to answers. Comprehension check questions. Okay, so first one, we have 8 questions. So can you try to answer these questions, okay? So next one, like after skimming the whole text, we move on to step number 2. In step 2, you read the questions and you underline keywords, right? Okay. For example, number 1, in what structure does gas exchange take place? The keywords should be structure, gas exchange. Please don't mute me, okay? Someone has just muted me. Please don't mute me. Don't mute the teacher. Now, number 2, keywords in number 2 should be molecules, process, diffusion. Diffusion is a very important word, right? So what does diffusion mean, right? Question number 3, do the alveoli deliver oxygen or carbon dioxide? Keywords are alveoli, right? What else? Deliver oxygen, carbon dioxide, capillaries, right? To the capillaries. Does oxygen or carbon dioxide diffuse from the capillaries to the alveoli? Keywords: oxygen, carbon dioxide diffuse, capillaries, and alveoli. Number 4, you are asked to describe the walls of capillaries, right? So keywords should be walls and capillaries. Number 5, what molecule inside the red blood cells carries oxygen? Keywords are molecule, inside red blood cells, oxygen, right? Number 6, why do alveoli need to be inflated? Keywords are alveoli, inflated, right? And number 7, what is surfactant? The important word here is surfactant, right? Number 8, where is surfactant produced? So the keywords are surfactant, one more time, and produced, okay? Now first, I wanted to take a picture of these 8 questions, okay? Use your phone to take a pictures and I will get back to the text for you to read and find out the answers for me, okay? Okay, so the first question is, in what structure does gas exchange take place? Get back to this paragraph. Okay, I think I will give you 1 minute to find the answers. Okay, Lý Nguyễn Vi Hồng, can you unmute yourself and communicate with me? You're not there. Lý Thanh Phương. Not there either. Mai Phước Minh Khang.
Yes, teacher.
Okay, so question number 1 for you. In what structure does gas exchange take place?
Gas exchange takes place between the alveoli and the pulmonary capillary in the lungs.
Yes, okay. Can you show the class where you can find the answers? In which paragraph and which line?
The paragraph 1 and the line 2 and 3.
Yes, very good answer. Thank you, boy. Okay, so the answer can be found in paragraph number 1, line number 2 and 3. Okay, you can see here, gas exchange takes place between the alveoli and the pulmonary capillaries in the lungs, right? Thank you. Now we have question number 2. When molecules are in the process of diffusion, what does that mean? So what does diffusion mean? Let me show you where you can find the answers. Okay, 1 minute for you to read. I read the question again. What molecules are in the process of diffusions and what does that mean? Ngô Quốc Phú, are you there? Nguyễn Đình Minh Khoa, can you hear me? Nguyễn Đinh Thuận Kiều,
Yes, I'm here.
you're Kiều, right? Okay, so Kiều, please, can you answer question number 2 for me? When molecules are in the process of diffusion, what does that mean? Can you explain diffusion?
Yes, I think diffusion is the next movement of molecules from one area that has a higher concentration amount of the molecule toward an area where there is a lower concentration of these molecules.
Yes,
Yeah.
that's right. Thank you, girl. So the
Yeah.
answer can be found in paragraph, the first paragraph, line number 2. So how does diffusion works? Diffusion is the next movement of molecules from one area that has a higher concentration, higher amount of these molecules towards an area where there is a lower concentration of these molecules, right? For example, when capillaries bring carbon dioxide to the alveoli, there is more carbon dioxide in the capillaries than there is in the alveoli. Therefore, the carbon dioxide will more likely move into the alveoli than out of them. Likewise, when oxygen molecules enter the alveoli, they are more likely to move into the capillaries where there are fewer oxygen molecules than stay in the alveoli where there are more oxygen molecules, right? That's how the diffusion works. Okay, so we move on to question number 4. Can you describe the walls of capillaries? The walls of capillaries. Okay, I think you'll need to answer these questions because it's quite complicated here. You need to describe the wall. Let's move on to the next question. What molecule inside of red blood cells carries oxygen? Okay, so the answer can be found in paragraph number 3 here. So I will give you around 2 minutes to read paragraph number 3 again and find, okay, again, a molecule which is inside of red blood cells carries oxygen. What is the name of that molecule, okay? Nguyễn Hoàng Sơn, are you there? Can you unmute yourself? Nguyễn Khánh Vi. Nguyễn Kim Trọng.
Hello, teacher.
Okay, you are Trọng, right? Okay, so I have a question for you. What molecule inside of red blood cells carries oxygen? So the keywords are red blood cells carry oxygen, right? Have you found the answer?
Hemoglobin carry oxygen.
That's right, okay. The right molecule is hemoglobin, but where can you find that answers? Can you show the class? Which paragraph, which slide, okay? Show them.
One inside the capillary oxygen enter red blood cell and then attack to hemoglobin.
Yes, the answer can be found in paragraph number 3, line number 4 from the bottom, right? Once inside the capillaries, oxygen enters red blood cells and then attaches to hemoglobin. Thank you, boy. Good. So the right answer is hemoglobin, right? Hemoglobin carries oxygen. The blood is now highly oxygenated and travels back to the heart via pulmonary veins, right? The process of gas exchange takes place simultaneously. In other words, oxygen is entering the capillaries at the same time that carbon dioxide is existing in the capillaries. Okay, so next question. Why do alveoli need to be inflated? So take a look at this one. The keywords is alveoli and inflated. Okay, so when you 1 minute to find the answer for that question. Why do alveoli need to be inflated? Phạm Thị Ái Trâm. Are you there? Not there? Phạm Thu Uyên.
Yes, teacher.
Okay, so can you answer that question? Question number 6. Why do alveoli need to be inflated?
To be inflated because in order for gas exchange to take place.
And what happens if alveoli are collapsed?
And if the alveoli are collapsed, then no air can flow into them, and there will be little oxygen to exchange.
Yeah, thank you for your answers. Okay, the answer can be found in the first sentence, right in the first sentence of this paragraph. In order for gas exchange to take place, right, the alveoli must be inflated, right? So you answer the question like alveoli need to be inflated in order for gas exchange to take place, right? Because if the alveoli are collapsed, then no air can flow into them and there will be little oxygen to exchange, okay? Now next, what is surfactant? What is surfactant? Phạm Trần Khánh Duy, unmute yourself and communicate with me.
Yes, teacher.
Okay, so what is surfactant? The keyword is surfactant, right? So what is that substance? What is that molecule?
Surfactant. Skip implied by a molecule called surfactant.
Now, so what is that molecule? Continue reading. Surfactant is a detergent.
Surfactant is a deterrent like molecule that prevent the alveoli from collapsing by mixing with the water that lie the inside of the alveoli.
Okay, thank you. You can mute yourself. You can, yes, mute yourself now. Surfactant, here the keyword. Surfactant is a detergent-like molecule, right? That prevents the alveoli from collapsing by mixing with the water that lies the inside of the alveoli, right? Number 8, question number 8. Where is surfactant produced? Tăng Khải Hoa.
Hello, teacher.
Okay, so question number 8 for you. Where is surfactant produced?
Surfactant is produced by large round cells in the wall of alveoli.
Thank you so much. Right. The right answer can be found in the last sentence, right? Surfactant is produced by large round cells in the walls of the alveoli, okay? So you see that, okay, if you have identified the right keywords will help you find the answers more effectively, okay? Sometimes you don't understand much about a text, but you can still find the right answers thanks to the keywords, right? Okay, so we continue with another reading practice, okay? Another text. How does, I'm sorry, the spelling mistake, respiratory system stays healthy? Can you just wait? Respiratory systems stay healthy. I'm correcting the spelling mistake here. Okay, and we can start now. So this is the text about how your respiratory system stays healthy, right? Okay, so as usual, I will give you about 2 minutes, okay, for skimming these two paragraphs, okay? Now, please read by yourself in 2 minutes before I show you the questions. Okay, so I think I will ask one student to read, okay, the paragraph for me. First paragraph. Can you just unmute yourself? Trần Đình Huy, are you there?
Hello, teacher.
Okay, so can you see the first paragraph?
I see.
Can you see it?
Yes, I see.
Okay, so can you help me read the first paragraph, please? How does the respiratory system stay healthy? Let's go.
The respiratory system plays an active role in helping us maintain our health. Teacher, can you help me?
Yes, I can hear you. Continue, boy. I can hear you very clearly. Continue. Starting
At the
beginning.
beginning of the respiratory system, the upper respiratory system filter airborne
Particles.
particles such as dust, bacteria, and virus. The virus and bacteria and other particles get trapped in the air of the nasal cavity
Nasal cavity, yes.
and the
mucus
of the
epithelial linings
line of the upper respiratory system and thus are prevented from entering our bodies and making us sick. What happened to this virus and bacteria lining mucus? We spit out, blow out, and swallow this mucus.
Okay, thank you so much. Trần Đoàn Hải Ngân.
Yes, I'm here.
Okay, so let me show you the second paragraph. Please continue reading. Why nasal hairs?
Why nasal hairs and upper respiratory mucus trap a lot of particles. Some particles still manage to get past these barriers. However, they can still be caught by cilia among the trachea. Cilia are miniature hair-like structures attached to the cells that line the trachea. This region also has mucous membrane to produce mucus. The mucus traps the particles and the cilia push the mucus upward to the throat to be swallowed or spit out.
Thank you so much. Okay, class, so your friends have just read two paragraphs for you. Now we move on to step 2. When I show you the questions, please read the questions first and underline some keywords. Try to identify some keywords in the questions. So we have the first question. What are the 2 ways that the respiratory system helps to filter out bacteria and viruses? Right? Keywords are 2 ways, right? Respiratory system, filter, right? Bacteria and viruses, right? Question number 2. What are the cilia and where are they found? Keywords are cilia, right? And where found. I will give you 2 minutes to find the answers to these 2 questions. Remember that the keyword in the first sentence is filter, right? Filter is verb. Very important verb that you need to find. Trần Ngọc Minh Thư. Hello Minh Thư, are you there? Trần Ngọc Minh Thư. Trần Thị Ngọc Yến.
Hello, teacher.
Yes, you are in, right?
Yes.
Your voice is echoing. Okay, so can you mute yourself, please? Trần Thị Thủy Tiên. Let me just call another student because Yến voice is echoing. Something is wrong with her microphone. Trần Thị Thủy Tiên.
Hello, teacher.
Yes, okay. Can you see the first questions? You answer the first question for me. What are the two ways that the respiratory system helps to filter out bacteria and viruses?
The two ways that the respiratory systems have to filter out the bacteria and virus are the hairs of the nasal cavity and
Good.
the
The first way,
mucus.
okay, so the first one, we can say the first way is that particles such as bacteria and viruses, okay, will be trapped in the hairs of the nasal cavity. So hairs of nasal cavity is the first way, okay, they will trap, okay, the particles. That's right. So what is the second way?
The second way is the mucus of the
Epithelial
linings of the upper respiratory system.
Yes, that's right. Second way is the mucus, okay, of the epithelial linings of the upper respiratory system. Okay, we have trap, okay, the particles too. Thank you. Okay, and we still have like the third ways. If you continue reading, you can find the third ways. Why nasal hairs and upper respiratory mucus trap a lot of particles. Some particles still manage to get past these barriers. However, they can still be caught by cilia. So cilia is the third way to help, okay, the body trap the particles. Okay, so they can still be caught by cilia along the trachea. So what is cilia, right? So number two, what are the cilia and where are they found? Trương Minh Hiếu, can you unmute yourself? No. Trương Ngọc Linh. Trương Ngọc Linh, can you hear me? No. I couldn't hear you. You need to check your microphone. I couldn't hear your voice. Trương Quế Nguyệt. Not there either. Võ Minh Huy.
Yes, I'm here.
You are Huy, right?
Yes.
Okay, so can you answer question number two? What are the cilia and where are they found?
The line number 3 in paragraph 2 is cilia are miniature hair-like structures attached to the cells that line the trachea. Trachea, yeah.
Okay, that's good. Okay, so you have just answered question number two, cilia. So cilia are miniature hair-like structures, right? And where are they found? They are attached to the cells that line the trachea. So cilia can be found inside your trachea, okay, in the cells of your trachea. Thank you, Huy.
You're welcome.
Okay, so as you have known that trachea, I'm sorry. So the cilia, okay, inside the cells of your trachea will help your body trap the particles too, right? So there are like three ways that your body can keep itself from getting the particles. Okay, can protect itself from particles. First one, the hairs of the nasal cavity will trap the particles. First way, right? The second way, the mucus of the epithelial linings of the upper respiratory system will help trap the particles too. And the third way, cilia, which are inside the cells of your trachea, will help trap the particles too. Okay, so we continue. Okay, so the next question I have, what is the function of cilia? Okay, what is the function of cilia? Nguyễn Hoàng Nam, can you unmute yourself and answer question number 3?
Teacher.
Your voice is echoing.
Uh,
Okay, can you hear me now? Can you say something?
yeah.
Okay, so question number 3 is for you. What is the function of cilia?
Mm, the function is cilia are miniature hairline structure attached to the cell that line the trachea.
Okay, so what is the function? So how does cilia work? The function. Okay, so can you read the first sentence from paragraph number 2? Why are nasal hairs? Let's go.
White nasal hair are upper respiratory mucus have a lot of particles. Some particles still manage to get past the hairs.
However, continue.
However,
However,
can still be caused by cilia along the trachea.
trachea, yes. Okay. However, they can still be caught by cilia along the trachea. So what is the function of cilia again? Cilia traps particles, right? Okay, because some particles will get through your nasal hairs, right? And will get through the mucus, okay? But like when particles get inside the trachea, okay, the cilia will help to continue to help trap the particles, right? Okay, so I said again, the function of the cilia is to trap particles, okay, which get through the nasal hairs and mucus, right? Thank you.
Yeah.
Okay, so we have the next two paragraphs. 2 minutes for you to skim read these two paragraphs first before I show you the questions. Okay, Nguyễn Hữu Phát. Sorry, Hữu Phát, not Hữu Phát. Nguyễn Hữu Phát.
Yeah, I'm here.
Okay, so can you continue? Helping me read the next paragraph, please. Within the lungs.
Within the lungs, there are two more ways to help us maintain our health. First,
Health.
health. First, there are special cells in the alveoli that can eat dust, bacteria, virus, and other particles that help escape filtration. The cells are called alveolar macrophage. The big eater wander around freely in each alveolus and eats any particle that help escape area means of filtration.
Okay, thank you, boy. You can mute yourself now. Okay, so next student, please. Nguyễn Khánh Vi, can you unmute yourself and continue reading the second paragraph for me? Thank you.
Hello, teacher.
Yes, please help me read the second paragraph.
Second, the respiratory system keeps us healthy because the lungs have the ability to heat and moisten the air. We breathe near the smallest bronchioles and the alveoli in the lung. It a rich network of capillaries that release heat and moisture. When air passes through this portion of the lung, it is warmed and moistened. This prevents the lung from drying out and make it easier for gas exchange to occur.
Okay, thank you. Now let me show you two questions. Question number 4, where are macrophages? Okay, where are macrophages found? And number 5, why is it important that the lungs heat and moisten the air we breathe? Okay, so 2 minutes for you to find the answers. Remember to pay attention to the keywords. So in number 4, the keywords are macrophages, right? Found. In question number 5, the keywords are why, important, lungs, heat, moisten, air, breathe, right? 2 minutes for you to find the answer. Okay, so have you found the answers for first questions? Our keyword is macrophages, okay? Đặng Trần Hồng Phúc.
Hello, teacher.
Yes, okay, so can you give me your answers for question number 4?
Yes.
So where are macrophages found?
Macrophages are found around freely in each alveolus.
Okay, so can you show the class in which paragraph and which line you can find the answer?
I can find the answer in the paragraph 1, the line number 1 and 2 in the bottom.
From the bottom, right? These cells are called alveolar macrophages. Macro means big and phage. Phage means to eat. So these big eaters wander around freely in each alveolus and eat any particles that have escaped earlier means of filtration. So macrophages can be found in alveolus, in each alveolus, right? Okay, thank you.
Yes, thank you.
Next students, Lê Thị Quỳnh Anh. Quỳnh Anh,
Yes.
please. Okay, so question number 5. Why is it important that the lungs heat and moisten the air that we breathe?
To prevent the lungs from drying out and make it easier for gas exchange to occur.
Very good. But where can you find the answers? Can you show your friends?
I find in the paragraph to the final line.
Yes. The last sentence of paragraph number 2, right? Okay. So if you read a sentence before, when air passes through this portion of the lungs, it is warm and moistened. So warm and moistened are the two keywords which can be found here, right? This prevents the lungs from drying out and makes it easier for gas exchange to occur. Thank you. Okay, class, so now we continue, okay, to review. I'm going to show you some questions, okay, related to the respiratory system. Get ready to answers, okay? But first, let me, like, take a look at the student list, okay? I'm taking a picture of your student list to make sure that I'm giving everyone a chance to communicate with me, because I don't want to call one student over and over again, okay, too many times. So let's just call the other student. Please wait. I'm taking a photo of the student list. Can you just wait? I'll be very quick. So we have like some guests here in my class. I see the word guest after your friends. After your name, I see the word guest. So you are guest. Does that mean you're coming from another class? Okay, so now please wait, showing you some questions. Okay, so first one, take a look at the first 8 questions. Okay, so let's see. You can answer these questions or not. Okay, so these following questions are about the respiratory system. Okay, so let's go through the questions first, and I will give you time to find the answers. Okay, number 1, what two cavities sends air to the pharynx? Number 2, what is the purpose of cilia in the respiratory system? Next to the alveoli, bronchi or bronchioles. Number 4, where does each of the 5 bronchi go? Number 5, which two muscles contract to cause inspiration? 6, in asthma, what two things happen to the bronchioles? 7, explain what diffusion is. And number 8, how do phagocytes protect the lungs? Okay, so I think I will give you around 5 minutes to find the answers to these 8 questions. Okay. In question number 8, the word like phagocytes. Okay, phagocytes is just another word for macrophage, right? In the reading we have macrophage, and here we have phagocytes. Okay. Okay, so let me just give you the meaning of phagocytes. Phagocytes is the white blood cell, okay, or a blood cell that destroys foreign bodies and cells in the body, right? The white blood cell that destroys foreign bodies and cells in the body, right? So just like the macrophage, right? Phagocytes can eat, okay, can eat the particles which get through to your lungs, right? Now, when I call your name, please unmute yourself and communicate with me, okay? When you give me a wrong answer, it's okay. Bùi Hữu Nghĩa, can you unmute yourself?
Yes, teacher.
Okay, so can you see question number 1?
Yeah.
Please answer question number 1. What two cavities send air to the pharynx?
That cavity are oral cavity and nasal cavity.
Very good. Excellent answers, okay? So the two cavities that send air to the pharynx are cavity and nasal cavity. Excellent answers. You can mute yourself. I'm happy that you remember. Cao La Phương Đông.
Hello.
Okay, so question number 2 is for you. What is the purpose of cilia in the respiratory system?
Cilia to cut the small molecules that get through he, the nasal hair.
Yes. Okay, so I have another question for you. Where can you find cilia? Where is cilia? Where can you find cilia? Is it inside your nose? No.
No.
Where is it?
I guess I
Do you
forgot.
remember? Huh? You forgot?
Yes.
Cilia can be found inside the cells in your trachea, right? Okay. So when the particles get through your nasal hairs, right, down to your throat and down to the trachea, right, and the cilia, okay, inside your trachea will trap, okay, the particles, will catch or will trap the particles. Understand?
Yes.
Okay, thank you. Number 3, Châu Ngọc Phụng. Châu Ngọc Phụng,
Yes,
question number
teacher.
3, yes. Can you answer question number 3 for me? Which structures connect to the alveoli, bronchi or bronchioles?
Bronchi.
No, not bronchi. Bronchioles, right? Bronchioles connect to the alveoli. You see, remember at the ends of each bronchiole is the alveolus, right? Okay, not bronchi. Okay, thank you, girl. Number 4, Châu Văn Hiền Nhân.
Yes, teacher.
Question number 4 for you. Where does each of the 5 bronchi go?
The next step bronchi will go to the bronchioles.
Where does each of the 5 bronchi go? So just to remember that air will travel through the trachea, okay, and trachea will branch into 5 bronchi.
And
So
yes, and the next and air go to the bronchi, and next air go to the bronchioles in the alveoli.
Okay, so just to remember, like we have 3 types of bronchi. So can you tell me that, like, what are those 3 types of bronchi?
3 type bronchi. Primary bronchi,
Yes.
secondary bronchi, and the tertiary bronchi.
Very good. First one is primary bronchi, and then
the secondary bronchi, and the last
bronchi,
is the tertiary bronchi.
Tertiary bronchi, and they will all go to your lung. Okay.
Yes.
So I have one more question for you. Just you remember we have the right lung and the left lung, right? Okay.
The left is smaller than the right.
Yes.
Yes.
Left lung is smaller than the right. So, you know, like there are like 3 bronchi going to the right, okay, lung, and 2 bronchi will branch into the left lung, right? Okay. Thank you so much. Okay, so next question, we have number 5. Which 2 muscles contracts to cause inspiration? Chu Quang Thắng.
Hello, teacher.
Okay, so question number 5 is for you. Which two muscles contract to cause inspiration? Do you still remember?
Sorry, I'm not sure about that.
Okay, so you just give me your answers, even though you're not sure. It's okay to give me a wrong answer. Okay,
I
so
don't. Yeah,
just imagine when you breathe in, when you get in oxygen, you breathe in. Okay, so what are the two muscles which contracts?
I do not remember exactly.
Okay, thank you, Hang. Okay, I'm calling another student to help you. Đàn Thị Giang.
Yes, I'm here.
Okay, so can you help your friend with question number 5? Which two muscles contract to cause inspiration?
The diaphragm and the last muscle that separates the abdominal cavity. To
Yes. Okay, the first muscle, okay, which contracts is your diaphragm. Very good, diaphragm. Okay, so diaphragm is the muscle which separates the thoracic cavity from the abdominal cavity, right? And the second one, where is the second muscle which contracts? You might not remember, but the second muscle is intercostal muscle. Remember? Okay, intercostal muscle can be found between the ribs. Okay,
the muscle between the ribs.
Yes, intercostal muscles. Okay, thank you, girl.
Yes.
Question number 6, you'll need to answer question number 6 because like we haven't learned about asthma. Don't worry, we skip question number 6, okay? I just asked you, okay, the questions that I've taught you already. So we skip number 6. Number 7, explain what diffusion is. Okay. Đặng Vĩnh Hiển.
Yes, I'm here, teacher.
Okay, so for question number 7, can you explain what diffusion is in your own words? Don't read the words from the book, explain in your own words. Use English.
Diffusion. I'm not sure I can answer that.
Okay, so if you have the book or the material inside by your side, you can find the word diffusion. And you find diffusion and explain diffusion one more time.
I'm sorry, I don't remember.
Okay, so that's okay. I'm calling someone to help you. Thank you. Đào Anh Khoa. Not there. Đào Trúc Minh Tú. Not there either. Đinh Phạm Trúc Vi. Đỗ Phương Thảo. Don't worry if you give me the wrong answers. Đỗ Thị Mỹ Trinh. Đoàn Hà Vi. No one is speaking. Why? Đoàn Hồng Nam.
Hello, teacher.
Okay, so can you help me explain what diffusion is? If you find it hard, you can use Vietnamese. So what diffusion is?
I think diffusion is
process. When a gas is spreading through a surrounding substance.
Is that the right definition of diffusion?
I think so. I just plans on my own. It's planned on my own.
Okay, thank you, boy. Okay, so let me explain again. Diffusion, okay, is a process, okay, in which, okay, like molecules, okay, tends to move, okay, to the area where there are many molecules of the same kind, right? Okay, so as again, molecules have a tendency, okay, to move to the area, okay, where there is a high concentration of those molecules, right? Okay, so diffusions will take place when the gas exchange happens inside your lungs, right? When you breathe in oxygen, you still remember we breathe in oxygen, okay? You see, like the pulmonary veins will carry, like the carbon dioxide, okay, the carbon dioxide, the oxygenated blood, poorly oxygenated blood inside the capillaries to the capillaries, okay? And at the capillaries, you see, like there is a lot of carbon dioxide, and oxygen will go through the membranes, okay, and go through your capillaries, okay? So oxygen, and then your blood will become oxygenated, right? And CO2 will pass through the membranes, and CO2 or the carbon dioxide will be exhaled, okay, out of your body. Okay, so I just like say again, diffusion, okay, is, okay, diffusion can be defined that molecules have a tendency, okay, to move to the area where there is a low concentration of the same kind of molecules, right? Okay, if that area, for example, we have like area A and B, so area A is full of oxygen and area B doesn't have any molecules of oxygen, right? So oxygen will move to area B, right? That's how diffusion works. Molecules, okay, move to areas where there is a low concentration of the same molecules, okay? Okay, so for question number 8, we have, how do phagocytes protect the lungs? Đoàn Hữu Lê. Đoàn Hữu Lê, are you there? No. Đoàn Lê Kim Tước.
Yes, teacher.
Okay, so can you answer question number 8? How do phagocytes protect the lungs?
I think that phagocyte will eat the particle.
Excellent answers. That's it. Okay. So in the readings, okay, we know that's from the reading. Okay, macrophage, right? Macrophage will eat, okay, the particles. So just like macrophage, phagocytes will eat the particles, okay, inside your lungs. That's it. Thank you. Excellent answers. Okay, so we move on to label the figure with the terms provided. Can you label this respiratory system with the right phrase? Okay. Number 1, when I call your name, please unmute yourself and label number 1. Đoàn Ngọc Anh. Đoàn Ngọc Anh, please. Dương Hữu Tuấn.
Hello, teacher.
Okay, so can you help me label this picture? Label the respiratory system, okay? Now let's start. Number 1.
Number 1 is nasal cavity.
Okay, nasal cavity. Good. Number 2.
Number 2 is oral cavity.
That's good. Number 3.
Number 3 is pharynx.
Pharynx. That's right. Number 4.
Number 4 um, Number 4 is territory bronchi.
You think so? I think number 4 is tertiary bronchi. Okay.
Sorry, number 4 is secondary bronchitis.
Yes. Number 4 should be like not tertiary but secondary bronchi.
Yeah,
Number
yes.
5. Number
Number
5.
5, lungs.
Lungs. Very good. We have like the right lung and the left lung, right? Number 6.
Number 6 is trachea.
Yes. Number 6 is trachea. Can you say again? Trachea.
Trachea.
Number 7.
Number 7 is primary bronchi.
Yes. Bronchi. Okay. Primary bronchi.
Asthma.
Good. Number 8.
Number 8 is tertiary bronchi.
Yeah. Tertiary. Can you say again? Tertiary bronchi.
Tertiary bronchi.
Very good. Okay. And number 9.
Number 9 is alveolus.
Yeah. Alveoli. Alveoli. Okay. And number 10.
Number 10 is bronchial.
Yes. Number 10 is bronchioles. Can you say again? Bronchial.
Bronchial.
And alveoli. Okay. Thank you, boy. You're very good. Okay. So class. So the right order. Okay. So when you put these organs, okay, these part in the right order. So remember trachea. Okay, downward from the trachea we have primary bronchi, right? And then primary bronchi we branch into smaller bronchi, which are called secondary bronchi, right? And then they will continue branching into smaller branches, which are called tertiary bronchi, right? And then we have bronchioles. Okay, and at the end of each bronchiole we have alveolus or alveoli, right? Okay, thank you so much. Now next, can you answer question number 2 here? When a person exercises, which of these will occur? A. Dilation of bronchioles, or B. Constriction of bronchioles. Okay, so let's see. How can you answer this one? Dương Viết Khải. Okay, so question number 2. Can you see question number 2? Can you answer that? Can you try answering question number 2? If you give me a wrong answer, it's okay. When a person exercises, which of these will occur? A or B? Dilation or constriction?
A.
Yes, A is the right answer. Why? Can you explain why?
I don't know.
Okay, so first one, do you understand the meaning of dilation? Dilation means getting wider, getting bigger, right? And
Yes.
constriction means getting smaller. So why? Why do bronchioles get bigger when we exercise? Because we need, when we exercise, we need more oxygen to breathe, right?
Yes.
Okay, so that's why the bronchioles will get bigger to absorb more oxygen. Okay, and oxygenated blood will be carried, okay, throughout your body. Okay,
Yes.
will return to your heart first, and your heart will pump oxygenated blood, okay, throughout your body, because when you exercise you need more oxygen. Okay,
Yes, teacher.
thank you. Okay, so question number 3, is it true or false? Another tricky question, but you can try giving me your answers to see whether you understand the question, the lesson or not. Hàng nghĩa nhân văn.
Hello, teacher.
Okay, so for this question, number 3, is it true or false? Okay, just tell me your answers. Your lungs inflate because air has filled them.
It's false.
It's false, very good. Okay, but why is it false? Can you explain to the whole class? False is the right answer, but why is it false? Can you explain why? Okay, so if you find it hard, I will ask another student, okay, to explain. Thank you, Nhân Văn. Hà Hoa Kiều Anh.
Hi.
Okay, so your friend said that this statement is false. Do you agree with him? Your lungs inflate because air has filled them. False. Do you agree with him?
Sorry.
Sorry, white. Okay, so thank you, girl. Let me give you the answers. The answer for this one is false. Okay, your lungs inflate. Okay, like it does not mean that your lung, okay, is filled with air. Okay, so your lungs inflate first when you breathe in, right? Okay, so remember the diaphragm. Diaphragm contracts. Okay, contracts to give more space inside your lungs. Okay, and then the air comes in. Okay, so that's why you mean that, okay, your lungs inflate before the air comes in. Okay, diaphragm contracts to give more space to the lung, right? When we breathe in, and when we breathe out, your diaphragm relaxes. Diaphragm will relax, okay, and then that's, okay, the time when we breathe down, okay, carbon dioxide. Okay, so this is the false statement. Okay, your lungs inflate before air comes in. Okay, not because air has filled them. Okay. Question number 4. Hồ Đăng Hạnh. Can you choose the correct word for me? When you speak, your vocal cords contract, relax, or vibrate. Hồ Đăng Hạnh, are you there? Hồ Thị My. Hồ Thị My, are you there? Not there. Hoàng Nguyễn Đức Anh. Hoàng Thị Thanh Thúy. Hữu Bình. Huỳnh Gia Bảo.
I'm here, teacher.
Okay, so can you choose the correct word? And number 4 for me. When you speak.
Your vocal cord vibrate.
Yes, very good. Your vocal cords vibrates, okay? Not contract or relax, vibrates. Thank you, okay? That's that's a quite easy question. Now, number 5, so-called the correct words. Contraction of the diaphragm or bronchiole causes the thoracic cavity and the lungs to. This causes a difference in weight or pressure of the air inside the lungs as compared with outside. Air will the lungs. Okay, so Huỳnh Lê Bảo Sơn, can you unmute yourself and have a guess? Remember that
Yes.
when you give me a wrong answer, it's still okay. Okay? No punishment for wrong answers. Can you read number 5 and choose one correct word? Contraction.
I don't know, teacher.
Okay, you don't know.
Ấy,
Okay,
da-
just the answer now.
diaphragm.
Yes, can you read the sentence? Contraction.
And guess I don't know.
Okay, so I will ask another student to help you. Don't worry. Huỳnh Thị Diệu Vi.
I'm here, teacher.
Okay, so can you speak a little bit louder? Okay, so can you choose the first one for me? Contraction of what? Diaphragm or bronchioles?
Diaphragm.
Yes. Okay. Contraction of diaphragm causes the thoracic cavity and lungs to. Next girl, expand or get smaller.
Get smaller.
Get smaller. Are you sure? Okay. I couldn't hear you clearly. Can you like? Okay, so you can mute yourself now. Let me call another student. Huỳnh Thị Ngọc Hân.
Hello, teacher.
Okay, so the first answer is contraction of the diaphragm, right, causes the thoracic cavity and lungs to. Your answers.
Expand.
Very good. Expand. Okay, when your diaphragm contracts, okay, your diaphragm contracts to give more space to your lung, right? Your lung will expand and then air comes in, right? Okay, continue, girl. This causes a difference in weight or in pressure
Yeah,
of
in
the air.
pressure.
In pressure, very good, of the air inside the lungs as compared with outside. Air, continue, air will rush into or leave the lungs.
Air will brush into the lungs.
That's right. Okay, your lung gets bigger. Okay, and air comes in. Air rush into and comes in your lung. Excellent answer. Thank you. You can mute yourself. Huỳnh Thị Thu Hà. Number 6 for you. Can you choose the correct words? You're not there. Lê Minh Đức Tài. Not there either. Lê Mỹ Huyền.
Yes, I'm here.
Okay, so can you give it a try for number 6? Inside the lungs.
Oxygen diffuses into the alveoli.
Okay, so your answer is inside the lungs, oxygen diffuses into the alveoli. Okay, so the first one is correct. Oxygen is correct. But like, where does oxygen diffuse into? Alveoli or capillaries? Okay, so let me ask you the first question. You still remember the pulmonary vein, right? Pulmonary vein will carry the oxygenated blood to the capillaries. So capillaries will carry the oxygenated blood, right?
Yes. Yes.
So inside the lungs, oxygen diffuses into
Um, inside the ring. Into
Do you still remember the process of diffusion? So what does diffusion work? Molecules tend to move from the area where there is a high concentration of them to the area where there is a low concentration of them. So in this case, inside our lungs, oxygen diffuses into capillaries. Okay, into capillaries because capillaries carry the oxygenated blood. Okay, and oxygen will diffuses into capillaries, and in that time, the oxygenated blood will be turned into oxygenated blood. Right? Understand? And oxygenated will travel back to your heart before being pumped to other organs of your body. Okay, thank you.
yes.
Okay, so for question number 7, what is the function of the respiratory system? This is a general question. Okay, you need to answer number 7. You can find the answer by yourself. Question number 8, where does incoming air go after it leaves the trachea? You can answer this one. Lê Nguyễn Phương Anh. Okay, Lê Nguyễn Trường. Sorry, Lê Nguyên Trường.
Hello.
Okay, so can you answer number 8, please?
Hello, teacher.
Yes, I can hear you.
Number 8, right?
Where does incoming air go after it leaves the trachea?
The air will go to the nose, right?
No, after it leaves. Okay, so air will, like when you breathe, air will go through your nose, down to your pharynx, and down to the trachea, right? So,
yes.
Where does air go after it leaves the trachea?
They will go to the bronchi.
Yes, the bronchi. How many types of bronchi have I taught you? How many types of bronchi? 3 types, right? Primary bronchi. What else?
Sorry, I can't hear you.
You can't hear me? Okay. Thank you. You can
Bạn
mute.
chậm quá thầy ơi.
Really? Internet connection is bad? It's slow? Okay, thank you. There are 3 types of bronchi. I've taught you already. Primary bronchi, secondary bronchi, and tertiary bronchi, right? Okay. Okay, so you can find the answers for question number 9, number 10 by yourself. Okay, in the material, I just focus on some important questions. Okay, to help you review the old knowledge. Okay. Okay, class. This is the end of our today lesson. Okay. We'll start the lesson now. See you tomorrow. Tomorrow we will learn, okay, about medical terminology, okay, some basic medical terminology. Okay, thank you, class. Goodbye, class.
Goodbye, teacher.
Goodbye, teacher.
Goodbye.
Goodbye, teacher.
Goodbye,
Goodbye,
teacher.
teacher.
Goodbye, teacher.